In the previous video, we learned the power rule, and now we're going to learn the product rule. Now, on their own, the different rules, the different techniques serve a purpose, okay, and they do their job, but to be honest, until we get to the chain rule, which is going to be 2 more videos down the road, the beauty of them is not so apparent. So after you see the product rule today, you may be going, why do we want to do this? And maybe right now there's other ways you can do things, but trust me, when we get to the chain rule, you'll see how all these individual skills that you learned, the power rule, the product rule, the quotient rule, they all become very much of a purpose, very much weave together when you get to the chain rule, and then you'll really appreciate their technique and the different things you can do with them. So let's learn the product rule. Again, there's going to be a separate video for all the proofs for these rules in this section. So look at the links in the description and you'll be able to find it. Let's start off with the product rule. Every book does it slightly different the way they phrase it. Every teacher does it slightly different, but the technique itself is the same. And so let me show you what it looks like. They just say it differently. What you do is pretty much the same everywhere. All right. Okay, so what this is saying is that if you're going to take the derivative of a product, so you have the first function f times the second function g. If you're going to take the derivative of a product, you hold one of them constant or unchanged, okay? You leave one of the factors unchanged, you take the derivative of the other, and then to that, you reverse that. The one that you left unchanged, you take the derivative of and leave the other one. So that probably went like this. I don't blame you. But let's look at it. It goes like this. If you have f times g, hold f the way it is. So this one is unchanged. So this one stays put the way it was. This one is the derivative. This is the derivative with respect to x of g. Okay, so you leave the first one alone, take the derivative of the second, then you leave the second one alone and take the derivative of the first. Now, some teachers, they say it the other way around, and they'll say it's the second times the derivative of the first plus the first times the derivative of the second. So in other words, they switch these over. And it doesn't matter which way you add, does it? I mean, it doesn't matter if you add this one to this one or number 2 to number 1. So it doesn't matter which way you say it, but trust me on this one. Pick a way and say it the same way all the time. And you need to be rehearsing these rules. You need to have already got the power rule undergoing. Okay, if it's a power, I bring the power down, leave the inside, the x alone, take 1 off the power. So the product rule is the first times the derivative of the second, and these are the first, so this is the first factor. This is the second factor. So it's the first times the derivative of the second plus the second as is times the derivative of the first. Okay, so you need to say that and you need to rehearse that, and you can rehearse that while you're walking around the house, doing chores, I don't know, waiting in line at the grocery store or something. So the product rule goes, it's the first times the derivative of the second plus the second times the derivative of the first, and then you're going to add all that up if you can. So let's try something kind of straightforward, and let's say that we have y is equal to 2x plus 3 times 5x minus 6. So this is the first factor. This is the second factor. So y prime would be, now we're going to say it one more time before we do it, the first times the derivative of the second plus the second times the derivative of the first. So it's the first factor as is times the derivative of the second. The derivative of 5x is 5. The derivative of 6 is 0. Plus the second as is times the derivative of the first. The derivative of 2x is 2. The derivative of 3 is 0. So it's the first factor times the derivative of the second plus the second factor times the derivative of the first. And then you clean this up. So 5 times 2x is 10x, 5 times 3 is 15, 5x times 2 is 10x, minus 6 times 2 is minus 12. So y prime is 20x plus 3. Now, just to show you, the last time we did a problem like this was in the previous video, and we did the power rule, and we didn't know how to do the product rule. So what we did is we took this original y function and we would have multiplied it out. So let's FOIL out this original y function. And so you would have 2x times 5x is 10x squared. Then you would have had 3 times 5x is 15x minus 12x is plus 3x. And 3 times minus 6 is minus 18. So this is the original function if you had multiplied it out. And if you took the derivative of this, this would be the power rule. So you bring the power down, leave the x alone, take 1 off the power, and the derivative of 3x is 3. So this is 20x plus 3, and you can see you get the same answer. So one of the beauties of calculus, and one of the reasons I like it, is because unless the teacher says something like, I want you to use the quotient rule, or I want you to demonstrate the product rule so that they know that you know them. If you're just asked to take the derivative, you get to choose your strategy and play to your strengths, so that if you're better at one rule than the other, you can do that. But then you can use the other rule to double check your answer when you take the test. So if the test is like 50 questions and each problem is worth 2 points, do you want to check every single problem, or do you even have time to check every single problem? I don't know, but I can promise you that I would be double checking every single problem until I ran out of time, because I hate to have points taken off. But if this was a test that only had 2 questions, and so each question is worth 50 points, I would be double checking it, triple checking it, and doing every possible way I could get to, because I don't want to lose 50 points. So this gives you ways to check your answers. It's really kind of a lot of fun. All right. So let's look at f of x. I think that's just going to make you wonder about what's f and what's g if we do that. So let's call it y. 4x cubed plus 2x squared minus 3x. All right. So the derivative, we have a product. So when you are asked to take derivatives, you have to look at it and go, now is it just different terms being added and subtracted together like a polynomial? That's the power rule. If it's something times something else, that's the product rule. If it's something divided by something else, that's the quotient rule. So you have to take about 5 seconds. Okay, and the shape tells you the rule to use. Okay, so this is a product, something times something else. Doesn't matter how complicated they are, it's just something times something else. So it's the first times the derivative of the second. Okay, now all you have to do is focus on this 4x cubed plus 2x squared minus 3x and take that derivative like the other part's not there. So 4x cubed, the derivative of that is 12x squared, plus the derivative of 2x squared is 4x, and the derivative of minus 3x is minus 3. Now I skipped a step or two on there from the last video, but you should have been practicing problems, and so I bet you're doing this already in your head. And if not, just go over to the side and work it out. You can always pause this video. Plus the second times the derivative of the first, which would be 3, because the derivative of 3x is 3. Now you have to clean all this up. That's the bad part. This right here is the calculus line. Calculus. The rest of this is going to be algebra. So calculus actually tightens up your algebra skills quite a bit. Okay, so here we go. And I'm going to do the distributive property. So 3x times 12x squared is 36x cubed. 3x times 4x is 12x squared. 3x times minus 3 is minus 9x. Plus, then we're going to distribute this direction. So 3 times 4x cubed is 12x cubed plus 6x squared minus 9x. So when you combine all this, you get 48x cubed plus 18x squared minus 18x. Now, just to prove a point one more time, if you had multiplied this out instead of doing the product rule, you would have had y is 12x to the fourth plus 6x cubed minus 9x squared. And if you take the derivative of this, you would get the same thing. Now, and faster actually, probably a lot less errors. But I want to caution you about something. If on the test, the test instructions just say take or find the derivative. Do whatever rule you want to do. Okay, but if it says using the product rule, and you do this and say y prime is 48x cubed plus 18x squared minus 18x. Same answer, right? How many points do you think you're going to get for the right answer, the wrong method? And the wrong method means not the one the teacher asked for. If you give the right answer using a method the teacher did not ask you for, if they were specific, you will get 0 points credit, all right, because you didn't follow the rules. And basically what this says, if you had done it this way, if the teacher had asked you to do it using the product rule, to the teacher it sort of says, I don't know the product rule, I've forgotten the product rule, and so I'm going to do it this way. Okay, or worse yet, I don't care that you told me the product rule, so I'm going to do it my own way. All right, so either interpretation, not good. All right, so if the teacher tells you a specific rule to use and you use an alternate rule, expect no points at all, no partial credit, no nothing. Okay, but if they don't specify, you can do whatever you want to, other than cheat. Okay, so, or use your calculator to tell you. All right. Now this one's a little bit more complicated and it's going to work our algebra skills pretty intensely. So here we go. Now, for me, I have to go at a fairly quick speed or I start making a bunch of mistakes. All right. And you'll find your optimum speed where if you go too fast, you make mistakes. If you go too slow, you make mistakes. And you'll find your optimum speed and sort of settle in there. And that's the speed you want to go on the test. The speed I'm using on the video is because I'm trying to be clear about everything. It's probably not my optimum speed. So I hope I don't make a mistake here. And if I do, I guess I'll redo the video. All right, so we're going to take the derivative, except there's a problem. Derivatives do not understand square roots. They understand powers. So we're going to change these to powers as opposed to roots. All right, and now we're going to take the derivative. So let's rehearse. For the product rule, the derivative is the first times the derivative of the second plus the second times the derivative of the first. So you have to keep repeating that to yourself. So it's the first times the derivative of the second. Okay, so let's think. X to the 1/2. You bring the 1/2 down, leave the x alone, take 1 off the power. So 1 away from a half is -1/2. Okay? Minus, okay, the derivative of x is 1. Okay? Plus the second times the derivative of the first. So the derivative of x to the 1/2 is 1/2. Bring the power down, leave the x alone, take 1 off the power. 1/2 minus 1 is -1/2. Okay, plus the derivative of x is 1. So this is the calculus line. And now we do cleanup. Okay, so y prime is, this is going to be the FOIL method. So what we have is first 1/2 x. Okay, a base raised to power times the same base raised to power. You write the base down and add the powers. So it's going to be 1/2 plus a -1/2. Okay? Outside, x to the 1/2 times a -1 is -x to the 1/2. Inside, plus 1/2 x to the first, there's a 1 right here, times x to the -1/2. You write your x down and add the powers. And x times -1 is -x. So this is the first one. Plus, FOIL method again. X to the 1/2 times 1/2 x to the -1/2 is 1/2 x. Add the powers. Outside, x to the 1/2 times 1 is x to the 1/2. Inside, minus x times 1/2 x to the -1 is 1/2 x. Add the powers. Okay? And then minus x times 1 is -x. Okay? So here we go. This is 1/2. And this is 1/2 plus -1/2, or 1/2 minus 1/2 is 0. And anything to the 0 power is 1. So this is going to go to 1. So you just have 1/2. Minus x to the 1/2 plus 1/2. 1 plus a -1/2, or 1 minus 1/2, is 1/2. Okay? Minus x plus 1/2 x to the 1/2 minus 1/2 is x to the 0, and that goes to 1. So this is 1/2. This is x to the 1/2 minus 1/2 x to the 1/2 minus x. Okay. Okay, so this next line, and this is not anybody's favorite thing to go through all this. Here's your 1/2, and here's another 1/2. So those two make 1. Okay? And here's a minus x, and here's a minus x. So that makes minus 2x. You hanging in there? Okay. And then here's a minus x to the 1/2 plus an x to the 1/2. so they cancel each other out. And here's a 1/2 x to 1/2 minus 1/2 x to 1/2, and those two cancel each other out. So these are all gone, and this is your y prime. And usually when you get a nice cleaned up answer like that, you go, I bet there was an easier way to do this. Okay, so let's look. Okay, if you go back up here, do you see how these are conjugates of each other because it's the same terms, but the sign in the middle is different? So remember, conjugates give you the difference of two squares. So this literally is the square root of x times the square root of x is the square root of x squared, which is x. And x times x is x squared, and it's the difference. And if you take the derivative of this, it's 1 minus 2x, which is that. So about now you're like, okay, I really do not like the product rule, but I promise you, I promise you, you're going to like it when we get to the chain rule. The product rule, when you have something relatively simple times something else, okay, maybe it's easier to multiply it out. But when you have some of the things we're going to do in the chain rule, you need the product rule. All right. So let's do another one. And then we're going to kind of change tactics, find a tangent, and we'll be done. So what if we have y is equal to x to the fourth minus 6 times x cubed minus 2x? So we're going to use the product rule because I don't really want to multiply all that out. So it would be the first times the derivative of the second. The derivative of x cubed is 3x squared. The derivative of minus 2x is minus 2, plus the second times the derivative of the first. The derivative of x to the fourth is 4x cubed. Bring the power down, leave the x alone, take 1 off the power. There's a reason for why I say leave the x alone. It'll come up in the chain rule. All right. Now, so then when we multiply this out, we get 3x to the sixth minus 2x to the fourth minus 18x squared plus 12 plus 4x to the sixth minus 8x to the fourth. Now, some of y'all can probably do that in your head, but, you know, sometimes you're tired. Sometimes this is just not your strong suit, and that's okay. Slow down. Do a couple of extra steps. It's better to be a little slower and right than really speedy and wrong. Okay, so if you take the derivative, you should have gotten something like this. All right, let's do one more thing, and then we're going to do talk about the normal to a curve. All right, so what if we have a triple product? Because sometimes it's more than one thing times the other things. So remember, the product rule says it's the first, as is, times the derivative of the second, plus the second times the derivative of the first. So in effect, what you're doing is alternating who gets the derivative taken and then adding up your combinations, right? Right? Okay. So the derivative would be, you're going to take the derivative of the first and leave the other two the same. Then you're going to scoot down, take the derivative of the second and leave the other two the same. And then scoot down and take the derivative of the third and leave the other two the same. So we're going to take the derivative of the first. The derivative of 3x minus 2 is 3, leaving the other two alone. Plus, we're going to take the derivative of the middle. So the derivative of x plus 4 is 1, leaving the other two alone. Then we're going to scoot down and take the derivative of the third. And the derivative of 2x plus 1 is 2, leaving the other two alone. So you just go down the row, you take the derivative of the first one, leave the others alone. Derivative of the second one, leave the others alone. Derivative of the third one, leave the others alone. And if you kept going, you'd go derivative of the fourth, leave everybody else alone. So when you clean this up, and I'm going to leave that up to you. You can do this, right? Or do you need me to write it down? Maybe I should write it down. All right, so it'd be 3 times 2x squared plus x plus 8x plus 4 plus 6x squared minus x minus 2 plus 2 times 3x squared plus 10x minus 8. I'm not sure why I didn't combine that while I was going, but I didn't. So you get 6x squared plus 27x plus 12 plus 6x squared minus x minus 2 plus 6x squared plus 20x minus 16. So y prime turns out to be, after you add up like terms, 18x squared plus 46x minus 6. Okay? Now, in the previous video, we did find the tangent to a curve. All right? And in this one, I want to introduce a name that you may not be too familiar with. Find the normal. To f of x equals x plus 4, 3x minus 6 at x is equal to 2. And let's practice the product rule, even though it may not be your favorite at this moment. Product rule is actually kind of cool. All right, so to remember to find any equation of a line, because this is a line, it's a normal line. You're shooting for y minus y1 equals m times x minus x1. So you need a slope and you need a point. Those are the same two things you need for a line, whether you're doing algebra or whatever calculus. So let's do the slope. So to find the slope from a function, you take the derivative, right? Because the derivative is the slope function. So let's practice. The product rule is the first times the derivative of the second plus the second times the derivative of the first. So it is the first times the derivative of the second plus the second times the derivative of the first. So when you clean that up, you get 6x plus 6. All right? Now, if you calculate, because this is the slope function, and it wants to know what's going on at x is 2. So the slope at x is 2, it's 6 times 2 plus 6, it's 18. Now, be very careful. This is saying that somewhere along some curve, wherever you are, this is the slope of the curve at that point. So this is always, I don't care what they asked you up here, this is always going to be the slope of the tangent when you use the derivative, okay? It's always going to be the slope of the tangent at that point. Now, what's a normal? A normal is the perpendicular to the tangent. So if this is the tangent, your normal would be perpendicular to the tangent. And at that point, perpendicular to the slope of the curve, right? Okay, now how do you get the slope of a perpendicular if you know the slope of what it's perpendicular to? So if the slope of the tangent is 18, the perpendicular slope, so this is the tangent, the slope of the normal is the negative reciprocal. So you change the sign and flip it. Okay, so this is the slope we're going to use for the normal. So you have, even if it asks you for the normal, you have to go through the tangent to get to the normal. And for the point, we're just going to use that original function And at x is 2, y turns out to be 2 plus 4 times 6 minus 6. So y turns out to be 0. So your point is 2, 0. So when you run this through, y minus y1 equals m times x minus x1. Y minus 0 is equal to minus 1/18 x minus 2. So y is equal to negative 1/18 x plus 1/9. Okay? And just to show you, okay, this red part is the slope of the original function because the original function was y is equal to x plus 4 times 3x minus 6, which is this part right here. So the red is the original function. Okay? This green part is the tangent. I calculated up the equation for the tangent. And this blue part is the normal. All right, so look. See right here? So the red part is the curve. Here is the tangent right here. And here's the normal. So it's right here. Can you see it? Right in this section right there. Okay? So the product rule, let's rehearse one more time before we go. The product rule is the derivative of a product is the first times the derivative of the second plus the second times the derivative of the first, and then you do massive cleanup. Okay? Now, remember the proofs. The link to the proofs is in the description down below. Be sure you like the video and subscribe so you'll get updates as we go through building this. And then the next video is the quotient rule. And then there's some practice problems too for you to work with solutions. I've moved from just giving you all the answers to working them out because as you go through these derivatives, especially when we get to the chain rule, just telling you what the answer is not necessarily helpful. Okay, so I worked them out so you can see how they go. All right, so see you at the next video, which is the quotient rule.